Right now, at this very second, humanity is using about 18 terawatts of power. That's 18 trillion watts. Sounds impressive, right? Well, according to one Soviet astronomer in 1964, that makes us a 0.73 civilization. Not even a 1. We're barely a 3/4 civilization. And here's the kicker. The difference between where we are now and a Type 1 civilization, we'd need to increase our energy use 10,000 times. Type 2, 100 billion times. Type 3, try 100 billion times more energy than we use today. So either Nikolai Kardashev was onto something incredible about alien civilizations, or he just created the most depressing measuring stick in human history. Let's find out which. October 1963. The Cold War is in full swing. The space race is heating up, and a Russian astronomer named Nikolai Kardashev is staring at his radio telescope data, completely confused. He's picking up a signal from something called CTA-102, a mysterious radio source that seems artificial, too regular, too structured. Could this be it? First contact? Spoiler alert, it wasn't aliens. It was a quasar, a supermassive black hole eating a galaxy's worth of matter and burping out radiation. But Kardashev's wrong answer led him to the right question. If we did find aliens, how would we know how advanced they were? And here's where it gets interesting. Kardashev realized something genius. You don't need to know if aliens have mastered warp drives, teleportation, or intergalactic TikTok. You just need to know one thing. How much energy can they use? Think about it. Every major leap in human civilization has been powered by energy. Fire, steam engines, electricity, nuclear power. We're literally just fancy apes who got really good at setting things on fire and harnessing the consequences. So in 1964, Kardashev publishes this paper that basically says, hey, what if we rank civilizations like video game characters? Level 1, Level 2, Level 3? Except instead of experience points, it's petawatts. The original Kardashev scale had 3 types, just 3. And trust me, by the time we get to Type 3, your brain is going to hurt. But let's start small. Let's start with us, or rather what we should be. A Type 1 civilization can use and store all the energy available on its home planet. We're talking about 10 to the power of 16 watts. That's a 1 with 16 zeros behind it. To put that in perspective, if a typical power plant generates about 1 billion watts, a Type 1 civilization would need 10 million of them running 24/7. Or, they could just do it smart and harvest the sun. Every hour, every single hour, the sun delivers more energy to Earth than all of humanity uses in an entire year. We're living on a planet being constantly bathed in free energy, and we're still arguing about gas prices. It's like living next to a waterfall and complaining about your water bill. So, how does a civilization reach Type 1? Well, you'd need planetary-scale solar arrays, possibly space-based solar collectors, control over weather systems to optimize energy, mastery of geothermal, wind, hydro, everything. And the big one, nuclear fusion. Now, fusion is the game changer. If we crack sustained fusion, and we're getting close, we'd need to fuse less than 100 kilograms of hydrogen per second to power a Type 1 civilization. And guess what? Hydrogen is the main component of seawater. We're literally swimming in our future fuel source. It's like discovering your couch cushions are made of gold. Original estimate. Kardashev thought we'd reach Type 1 in 3,200 years, but physicist Freeman Dyson, we'll meet him properly in a minute, thinks we could do it in just 200 years. That's not some distant future. That's your great-great-great-grandchildren's world. So where are we now on the scale? Remember that 0.73 I mentioned? Yeah, we're not even at 1 yet. We're like a civilization stuck in the tutorial level trying to figure out the controls. Okay, Type 1 is impressive. Planetary mastery, total energy control. But here's where the Kardashev scale stops being about science fiction and starts being about cosmic horror. Because the jump from Type 1 to Type 2 isn't just big, it's incomprehensible. A Type 2 civilization doesn't just use the energy hitting their planet, they use all of it. The entire star, every photon, every watt. We're talking 10 to the power of 26 watts. That's 10 billion times more energy than a Type 1 civilization.
To put this in perspective, if a Type 1 civilization is a single candle, a Type 2 civilization is every nuclear bomb ever built, detonating every second, forever. And now we need to talk about the man, the myth, the absolute mad lad of physics, Freeman Dyson. In 1960, Dyson asked a simple question: if you wanted to capture all of a star's energy, how would you do it? And his answer was so audacious, so monumentally insane, that we named it after him, the Dyson Sphere.
Picture this. You take your star, let's use our sun, and you completely surround it with a shell of solar panels. A sphere with a radius of about 93 million miles. The sun sits in the middle, constantly pumping out energy, and your megastructure catches every single photon. Now you're probably thinking, wait, wouldn't that be impossibly massive? Yes, it would. To build a Dyson sphere, you'd need more raw materials than exist on Earth. Like, a lot more. You'd probably have to dismantle Mercury, maybe the moon too. You'd be strip mining entire planets just to get enough metal and silicon. It's the ultimate mega project. Hey boss, the construction timeline says we need to, checks notes, destroy several planets. Also, we're out of coffee. But here's the thing. Most scientists think a full sphere is actually overkill and maybe impossible to build. Instead, they talk about a Dyson swarm. Thousands or millions of smaller solar collectors orbiting the star independently. This is actually more realistic. You don't need one megastructure that could collapse catastrophically. You build it piece by piece, satellite by satellite. It's like the difference between building one impossibly huge spaceship versus building a fleet of smaller ones. And here's what's truly wild. If a Type 2 civilization exists out there, we should be able to see it. Remember, they'd be capturing almost all their stars' visible light. But stars also emit heat, infrared radiation. You can't hide that. Dyson actually suggested we should search for stars that are dim in visible light, but blazing in infrared. That would be the signature of a Dyson sphere, a star hidden inside a shell, and that shell is warm. So have we found any? Well, there's Tabby star, KIC 8428529, nicknamed Tabby star after astronomer Tabitha Boyajian. This star does something weird. Its brightness drops irregularly, by a lot, up to 22% dimming at times. That's not normal. For a while, some people thought, could this be a partial Dyson sphere under construction? Is this first contact? Probably not. The current best explanation involves dust clouds or cometary fragments. But the fact that we even considered it shows you how seriously scientists take this idea. Okay, deep breath. Type 1, control your planet. Type 2, control your star. You're probably thinking that's as big as it gets. But remember, Kardashev proposed 3 types, and Type 3 is where we stop talking about civilizations and start talking about gods. A Type 3 civilization has mastered energy collection and use on a galactic scale. We're talking about 10 to the power of 37 watts. That's 100 billion times more powerful than Type 2. At this point, numbers stop meaning anything. This is a civilization that has built Dyson spheres around hundreds of billions of stars. They've colonized their entire galaxy. They control black holes, harness their energy, maybe even live inside them. Oh yeah, black holes. Let's talk about those for a second because there's this wild concept called the Penrose process. Physicist Roger Penrose discovered that you can actually steal energy from a rotating black hole. There's this region called the ergosphere, where space-time itself is dragged faster than light. If you drop something into it at the right angle, you can extract up to 29% of the black hole's mass as pure energy. Let me say that again. A Type 3 civilization could be farming black holes like cosmic batteries. 29% of a black hole's mass. That's insane. But how would a civilization even reach this level? Well, there's this concept called von Neumann probes, self-replicating robots. Here's how it works. Step 1, you send a robot to another star system. Step 2, that robot uses local resources to build copies of itself. Step 3, those copies spread to more star systems. Step 4, repeat exponentially. If you do this efficiently, you could colonize the entire galaxy in just a few million years. Which sounds like a long time, but remember, the galaxy is 13.6 billion years old. A few million years is nothing. It's a cosmic eye blink. And this brings us to the most disturbing part of the Kardashev scale. If Type 3 civilizations are possible, if they could colonize a galaxy in just millions of years, if the universe is 13.6 billion years old, then where the hell are they? Welcome to the Fermi Paradox, named after physicist Enrico Fermi, who supposedly asked during lunch one day, "Where is everybody?" We've searched. We've looked at thousands of stars. We've listened for radio signals. We've looked for the infrared signatures of Dyson spheres. And we found nothing, not even a whisper. So what's going on? Are we alone? Are we early? Or is there something else? Enter the Great Filter. This is possibly the most terrifying idea in all of science. The Great Filter hypothesis says that somewhere between simple life and galaxy-spanning civilization, there's a barrier, a wall, something that almost no one gets past.
It could be behind us. Maybe the jump from single-cell to multicellular life is incredibly rare. Maybe developing intelligence is a 1 in a trillion shot. If that's true, we're incredibly lucky. We're special. But if the Great Filter is ahead of us, that means there's something waiting. Something that destroys civilizations before they reach the stars. Nuclear war? Climate collapse? Runaway AI? A technology so dangerous that every civilization eventually discovers it and doesn't survive? And here's the really messed up part. Finding alien life would actually be bad news for us. The more common life is in the universe, the more likely it is that the Great Filter is ahead, not behind. Because if life is common and we still don't see advanced civilizations, it means something is killing them all. This is why the Kardashev Scale matters. It's not just about energy, it's about survival. Every jump up the scale represents obstacles overcome, existential risks navigated, filters passed. So where does that leave us? Humanity. Civilization 0.73, not even a Type 1 yet. We're at a crossroads. We have the knowledge to reach Type 1 in maybe 200 years. We understand the physics. We have the technology emerging. Fusion is getting closer. Renewable energy is scaling. Space infrastructure is becoming real. But we also have the capacity to destroy ourselves. Climate change, nuclear weapons. The very technologies that could launch us forward could also pull us under. Here's the thing about the Kardashev scale that nobody tells you. It's not just a measurement, it's a challenge. It's the universe asking us, can you make it? Can you handle the power you're discovering? Can you be responsible with energy that could build a Dyson sphere or destroy a planet? Freeman Dyson thought we'd reach Type 1 in 200 years. That's roughly 9 generations. Your descendants could be the ones harnessing the full power of the sun. They could be the ones deciding whether humanity builds its first Dyson swarm, whether we spread to the stars, or we could be the civilization that almost made it. Another empty planet in a quiet galaxy. Another failed experiment in the cosmic laboratory. Nikolai Kardashev gave us a scale in 1964, a way to measure cosmic civilizations. But really, he gave us a mirror, a way to measure ourselves. And right now, at 0.73, we're still writing our story. The question isn't whether we can reach Type 1. The physics says we can. The question is whether we will, whether we'll cooperate, innovate, and survive long enough to take that step. So, what do you think? Are we going to make it? Are we alone in the universe, or just early to the party? And if the Great Filter is real, are we past it, or walking straight toward it? Drop your thoughts in the comments. And remember, every time you turn on a light, you're participating in humanity's journey up the Kardashev scale. We're all part of this, every single one of us.